Welcome to section 5.3, Make value types faster with ref_return. In the previous video, we discussed how we can avoid heap allocations with local functions. Now this time we move on to value types. We will discuss how the new ref_return feature can improve the performance when you work with value types. In this video, first we will look at the history of the ref keyword, then we will discuss how you can combine value types with the ref keyword to make your code faster. After we understand the benefits of the ref keyword, we move on to two specific C#7 features, which are ref_return and ref_local. After this video, you will understand why the ref keyword is very useful in combination with value types, and you will also understand the possible performance benefits of the new ref_return feature. Now in section 4, we talked a lot about value types. It's important to understand the basic differences between value types and reference types, so if you are not familiar with those concepts, then I suggest you to jump back to section 4 before you watch this video. Alright, now let's start with this very simple code. What we have here is a method called increment, which takes an integer as a parameter and increments this number. The first thing to note is that C# by default takes every parameter as value parameter. This means that a new storage location is created for the parameter, and the value that you pass to the method is copied to this new storage location. This means that we have the value twice, and those live independently. Therefore, when you run this program, the output from the main method will be 0, since what we incremented in the increment method was just a copy of the original value. Now to have a full understanding on this, let's talk about reference types a little bit. What we discussed before still applies. In this case, also a new storage area is created for the p parameter, and the value of the parameter is copied into this new storage area. But in this case, we have a reference type, and the value of a reference type is the reference itself. This means that we will have two references which reference the same object, but in this case we immediately set the value of the reference within the method to null, which is only a copy of the original reference that we created in the main method. So after the SUMRANDOM method finished, the main method will still have the original reference value, which references the person called Greg. Therefore, the person variable in the main method is not null. So the two samples behave the same. The changes of the copies are not reflected in the caller method. Alright, so let's go back to value types. What does this copying means for a value type? Well, it means that everything which is stored on the value type will be copied. This has two implications. As we already discussed, the changes within the method won't be visible after we return from the method to the caller, and second, well, as we said, everything will be copied, and that can be potentially a performance problem. Imagine a struct that contains 5 integer fields and let's say 4 other double fields, and all that is passed to a method that is called in a tight loop. While that can be lots of copying, with reference types we don't have this problem, since we only copy the reference and the size of the reference is independent from the size of the instance which it references. So in this sample code, if this myBigStruct is a really big struct, then there is lots of copying going on when this increment method is called. To solve this problem, already C# 1.0 offered a solution. We can use reference parameters, and in that case there won't be any new storage area created for the parameter. Instead, we use the existing storage area, so the value of the reference parameter and the value within the caller method are the same. We just have two references to this value. Now what's the implication of the ref keyword for value types? First of all, if you change the value, then the change will be also reflected within the caller method. So in this very small sample, the value of the integer from the main method will be changed within the increment method. Remember, we don't have a copy here, we have a single storage area, and we change that within the increment method. And from the performance perspective, the good news is that if you have a big struct, then it won't be copied in this case, only a reference is created, and in the previous scenario with the big struct we discussed before, this behavior is very positive for the performance. For completeness, let's quickly also talk about reference types and the ref keyword. You can also pass a reference type as a reference parameter, and the same we said before still applies. Here a reference to the person instance is passed to the SUMRANDOM method, and we set the value of this reference to null, and this change is of course reflected within the caller method. Remember, we have one storage area, and this storage area happened to be the reference itself, and that is what we changed in the SUMRANDOM method. So in case of a reference type, there is no real performance difference between using reference parameter and value parameters. In both cases, we just pass references, so the performance is basically the same, just the behavior is different. By the way, in C# there are two other ways to pass parameters. There are output parameters and parameter arrays. Since these are not relevant to our performance discussion, we leave those out. So let's summarize this. Already before C#7, we were able to use the ref keyword for method parameters. For value types, this means that when you pass a value type as a parameter into a method with the ref keyword, then you will avoid copying the value type, which has two consequences. If you change something on this value type within the call method, then the changes are reflected in the caller method. And second, in case of a big struct, the big value type won't be copied, and that is good for performance. So until this point, we talked about parameters, but what about return types? Well, here is where C#7 comes into the game. The ref return feature solves basically the same problem for return types. One interesting thing about this is that on the IL level, this was possible from the beginning, but only C#7 exposed this functionality to the C# language. So this is a plain compiler feature that basically generates IL code that is very performant for some use cases. So let's explore these. In the next minutes, we will look at two use cases of ref return. These are the two common use cases of this feature. In the first sample, let's say we want to select an item from an array within a method and then change its value in the caller method. First, let's take a look at the selectArrayItem method. It gets an array as parameter and a func which represents the selection logic. Imagine that you have some complicated logic that decides which item in the method is relevant. You can pass this logic into the method this way. Now what the method returns is not the value of the selected array item. What it returns is a reference to this item. So all we learned from input parameters is true here for the return value with ref. With references, you always have a single storage area that you can control through multiple references. So the main method creates an array, and then we immediately print the item at position 2. Its value is 3, so nothing impressive at this point. Then we call the selectArrayItem, which with our parameter returns a reference to the item we printed before, which is the item at position 2. And then we change the value through this reference to 99, and then we have the same console.writeLine again, and this time it prints 99. So the method returned a reference to a value type and not a copy from it. Now what does this mean for the performance in this particular case? Well, not really much. Here we returned a reference to an integer instead of the integer itself. But the size of these two are actually not significantly different. This scenario is actually not meant to boost the performance. Before C#7, you were only able to achieve this behavior with unsafe code. So the intention in this case is to avoid unsafe code. By the way, in a later section, we will also talk about new APIs. For example, we will talk about span, and the ref return language feature is the foundation of these kinds of APIs. Alright, so let's go back to our main topic, performance. Is this feature related to performance or not? Well, it's related to performance. Remember the discussion with big value types. Once your value type is big, then it makes sense to avoid copying it. Let's move on to another example where we want to return a big value type from a method. Let's say we have a struct that represents 3x3 matrices. Here is how the values are stored. They are just plain integers. Now please don't think about how you would implement it. The point here is that we have a value type whose size is significantly bigger than a size of a reference. In the selectMatrix method, we return either the first matrix or the second, depending on the value returned from the selection logic parameter. Now let's discuss what would happen if we would return the matrix directly, so without the ref keyword. Well, then it would be copied, and copying in this case means that all 9 matrix elements would be copied. Thanks to the ref keyword, we don't copy the matrix, we just return a reference to it. Now the size of a reference to this matrix struct is definitely smaller than its value. In the next demo, we will measure the performance difference of the matrix demo with and without ref return. So we have two methods here, one that we already know from the last slide, this is with ref return, and one that returns the matrix without the ref keyword. Then we have two matrices, and with each method we randomly select one of those in a for loop with 1 million iterations. Let's measure this with benchmark.net. Here are the results. As you can see, the GC usage in both cases is very nice. There is no pressure on the GC in this case, since things that we allocated are on the stack. But still, the implementation that not uses ref return is significantly slower, and that is due to the fact that we have relatively big structs here that we copy all the time. So in this case, the GC and the heap are irrelevant. All the copying doesn't happen on the heap. So two learnings here. First, you shouldn't always blame the GC and the heap, and second, ref return can help a lot if you return big value types. Okay, so we discussed the performance related characteristics of the ref return C#7 language feature. Although we focus on performance here, let's quickly discuss what you can return with the ref keyword and what you cannot. You can return with ref something that is allocated on the heap. This is what we saw in our first example, since we had an array in that case and that was allocated on the heap. You can also return something that was passed into the method as parameter with the ref keyword. This is what we saw in the matrix example. You can also ref return an out parameter, although honestly I don't see where this could be useful, but I'm sure there are use cases for that. Now there is one important thing, you cannot ref return a local variable. Now there is a related feature in C#7 called ref local, so let's talk about this quickly. Until this point we saw how to use ref parameters and ref returns. Ref local is basically the same within a single method, so similarly to reference parameters and ref return, you can also define local references. What you see in this small code snippet is that we define an x variable with value 1, then we define a ref local y that references the x value. So we have one storage area here, and both x and y are referencing the same storage area. Then we change the value of this storage area through y to 42, and then print its value through x, which is of course also 42. Similarly to ref return, you can of course also define a ref local to something more complicated, for example to an array item. And with that we basically reach the end of the video, so let's summarize what we learned here. So before C#7 we were able to pass reference parameters into a method, but we were not able to return a reference from a method. In C#7 there are two new scenarios where you can use the ref keyword, and these are ref return and ref local. For ref return we discussed two use cases, one where we returned a reference to an array item. The idea behind this is to avoid unsafe code, and the second use case was that we returned a relatively big value type. In C#7 for scenarios where we have big value types, we can return a reference to this value type, and with that we can avoid copying the big value type. The idea behind this is to improve the performance. Thanks for watching. I hope this video helped you to understand why the ref keyword is important if you want to optimize code that heavily uses big value types. In the next section we will take a look at the new tuple feature with its performance implications.